All right, so yesterday we did multiplying and dividing, rational expressions. Today we're going to do adding and subtracting. Adding and subtracting is very similar to what we do with fractions. If we had, let's say, 1/2 minus 1/4, you can't do that until you get a common denominator, right? In this case, a common denominator of 4. So we would make this, we multiply by 2/2, we have 2/4 minus 1/4. And now we can do our addition or our subtraction, okay? Very similar to rational expressions, okay? So we do have to have a common denominator to add or subtract. Now, in this case, oops, didn't mean that. In this case, sorry about that. X plus 1, this does have a common denominator, so I can go ahead and subtract. Now be careful with subtraction. It is x minus all of this. So make sure it's minus 3x and minus 2. So up top we'll have x minus 3x and x minus 2 over that common denominator. So here we can combine our like terms. X minus 3x is negative 2x minus 2. That's a minus. Over x plus 1. You still want to simplify if you can. So I see a GCF here of negative 2. When I divide by negative 2, I'm left with x plus 1. And I see that those can cancel. So it winds up simplifying to negative 2. Again, I still want to talk about restrictions in your domain. If you come back here, you know x cannot equal negative 1. All right, restrictions in your domain, you know x cannot equal negative 1 because negative 1 plus 1 is 0. No zeros in the denominator. Now if you look here, x plus 1, x minus 1, that is not a common denominator. That is not a common denominator. So we need to have an x plus 1 in our denominator and an x minus 1 in our denominator. So we're going to go ahead and make our denominator x plus 1 and x minus 1. You gotta have both. X plus 1, x minus 1. So in order to get that common denominator, you have to see what you added. So here we already had an x plus 1. We multiplied by x minus 1. So we have to do it to top and bottom. So we have to multiply bottom and top by x minus 1. So 3 times x is 3x. 3 times negative 1 is negative 3. Now here I have to multiply top and bottom by x plus 1 to get that denominator. X plus 1 to get that denominator. Again, distribute 5 times x, 5x, 5 times 1. Now that we have a common denominator, we can go ahead and add. So we have 3x's plus 5x's makes 8x's. And we have negative 3 plus 5. And over that common denominator, x plus 1, x minus 1. Again, factor, see if you can simplify. I see a GCF of 2 up top. So when we pull it out, we got 4x plus 1. Still the same denominator. And I don't see anything that cancels, so we're actually going to stop there. So sometimes they might not simplify, and that's fine. Here again, x cannot equal. It can equal negative 1 or positive 1. So positive or negative 1. There's our restrictions to our domain. All right, so again, adding and subtracting, make sure you have that common denominator. Make sure you have a common denominator. Now, you also want to use the least common denominator. Like if I had, let's think here. I don't know why I'm having a brain fart. 1/2, let's say, plus 1/4. Could you use a denominator of 8? Absolutely. Could you use a denominator of 16? Absolutely. Could you use a denominator of 32? But you don't want to, right? You want to use that least common denominator. Here, I would want to use a common denominator of 4. So you want to use the smallest denominator possible to make your life easier. So when we look at these, I'm going to go ahead and factor the first one. So the bottom, let's see what we got. Multiplies to 9, adds to -6. I'm going to put x minus 3 and x minus 3. Right? -3 times -3 is positive 9. -3 plus -3 is -6. And then the other one, that's a 7. X squared minus 9 is difference of squares, so we have x plus 3, x minus 3. So you have to make sure that you grab everything. So let's see what our common denominator is going to be. Well, we know both of them has an x minus 3, so we're going to grab one of those. This one actually has another x minus 3, so you do have to use it. And then this one has an x plus 3, so we have to use that as well. You could also write this as I need x minus 3 squared, right? You need 2 of them and an x plus 3. So that would be your least common denominator, your least common denominator between the two of those. All right, so let's practice finding a little bit harder denominators here. So we got x over, we're going to go ahead and factor. Got to be strong at factoring in this chapter. Multiplies to 25, adds to -10, so -5 and -5. Here we got x minus 4. I see a GCF of 2, so we're going to pull it out. 2 times x minus 5. And let's think about our common denominator. I know I've got to use an x minus 5, because they both have one of those. I know I have to use another x minus 5 because the first one has 2 of them. You can't get rid of it. And I know I have to keep that 2 as well. I'm going to put it out front though. So there's my common denominator. 2 and x minus 5 times x minus 5. Or you could write x minus 5 squared. Either way. So let's see what was missing. Here we had x minus 5, x minus 5. We just need the 2. So we're going to multiply top and bottom by 2. So we got 2 times x is 2x. All right, that one wasn't bad. Here we have a 2, we have an x minus 5. We just need that other x minus 5. So we're going to multiply top and bottom by x minus 5. Oops. And then this is going to be a FOIL. X times x is x squared. X times -5 is -5x. -4 times x is -4x. -5x, -4x makes -9x. And then -4 times -5 is positive 20. Now that we have a common denominator, we can go ahead and do our subtraction. Again, make sure with subtraction, it distributes to all of this. You're subtracting x squared, you're subtracting -9x, you're subtracting 20. So up top, we're going to have 2x minus x squared. Minus negative becomes plus 9x and minus 20. Over, I'm going to go ahead and make this x minus 5 squared. So 2 and then x minus 5. We have 2 of those. All right, let's simplify and go ahead and put this in standard form. So we'll put that x squared first. 9x's and 2x's make 11x and a minus 20 over 2x minus 5 squared. And we're done. We're done on example 8 there. So let me go ahead and box that in. And let's talk about our denominators. Again, look at your denominators. We can't have x be 5 in this case. That would be the only thing. So x cannot equal 5, because 5 minus 5 will get me 0. All right, moving on. So these are a little bit harder. this is one big division problem. One big division problem. I always work with the top, work with the bottom, and condense those first. So let's look at the numerator. It looks like we need a denominator of 2x. Common denominator of 2x so that we can combine those, which means I need to multiply this one by 2 and this one by x. So 2 times 1 gets me 2 over 2x. And 3 times x gets me 3x over 2x. And now you can combine this. 2 minus 3x. So 2 minus 3x over 2x. Alright, so we take two separate fractions and combine it into one single fraction. I usually make this line really, really bold so I know where my it winds up being way too many fractions. So let's look at the denominator. It looks like our common denominator down here would be 4x. So to get 4x, I would have to multiply top and bottom by 4. And here I would have to multiply top and bottom by x. So 4 times 1 is 4 over 4x. And 3 times x is 3x over 4x. And now that we have our common denominator, we can add 4 plus 3x over 4x. So now that we've combined this into a fraction and this into a fraction, remember this is division. This is division. We want to change it to multiplication. So we're going to do our keep, change, flip. Keep, change, flip. Keep 2 minus 3x over 2x. Change to multiplication, right? Instead of division, multiplication. And flip. So this is going to be 4x over 4 plus 3x. And now it goes back to what we talked about yesterday, multiplying. See if you can eliminate anything. I know divide by 2x, divide by 2x. All right. I don't see anything that'll cancel out there, so I'm just going to go ahead and write this. We got 2 times 2 minus 3x and 4 plus 3x. And we're done. I don't see anything that simplifies. Again, going back here, you know that x cannot equal 0. You know that x cannot equal 0 in the original. Now, you also need to look, so we're going to look at all of our denominators, because you know your denominator can never be 0. So here, we can't have a denominator of 0. Here, we can't have a denominator of 0 in this case. X cannot equal 0 still. But here, you know 4 plus 3x also cannot equal 0. So you do have to kind of look at everything. Start from the beginning and just look through all of your denominators. Make sure that they're never equal to 0. So we're going to subtract 4x. Sorry, 4. And we're going to divide both sides by 3. So we know x can also not equal negative 4/3. So we actually have 2 restrictions. So make sure you look through everything and see if you have any more restrictions. Okay. And last but not least, let's look at that numerator. We're going to get a denominator of x times x plus 7, right? We got to use everything. So x times x plus 7. Looks like we got to multiply top and bottom by x, and then top and bottom by x plus 7. So here we got x, here we got x plus 7, and all of that is over 7. So here we have x minus x is going to go away, and then you have a negative 7 over x times x plus 7. Keep, change, and then 7 over 1 becomes 1 over 7. That'll cancel with that. And up top we get negative 1 over x times x plus 7. And that one is done. Restrictions to your domain. X cannot equal 0. X cannot equal negative 7. Still 0 and negative 7. Still 0 and negative 7. That's a negative 7, sorry. And you're done. All right, bye guys.